As is the practice, I'm going to start my session with the polls. So according to my count, our 73 students are present today. 75 students are present today, and let me close the poll. We see that 70% of the students have answered it correctly, whereas 30% have answered it incorrectly. The question was simple. The question was comparison between a refrigerator and a heat pump. Okay, and we had discussed this many a times that both the heat pump as well as the refrigerator, they pump the heat from a lower temperature to higher temperature. Whether the whiteboard is seen? No? Okay. All right.
Yes, now it is.
Now it's seen?
Yes.
Okay. So as you see on the whiteboard, I have drawn this schematic of a heat pump and a refrigerator. Okay, and in both the cases, if you see the direction of the arrow, you would see that there is heat transfer from a lower temperature to a higher temperature in the heat pump also, and in the refrigerator also you see that there is a transfer of heat from the lower temperature to higher temperature. Okay, so the answer is in both the heat pump as well as the refrigerator, there is pumping of heat from a lower temperature to higher temperature. And this, not all of you understood, but 70% of the class has understood this. Okay, hopefully now it is clear to all that both the refrigerator and heat pump, there is the direction is from lower temperature to higher temperature. Now this is much more simpler. The students who have joined late, they won't be marked present today. Only the students who have attempted poll number 1, okay, they would be marked as present. The question is pretty straightforward. I'm asking you that whether the desired effect for both the refrigerator and heat pump is the same. So it means that I'll close the poll. Okay, so 78% of the students have answered it correctly. The answer is desired effect of both the refrigerator and heat pump are not the same. Okay, that is the answer. So the answer is false, of which 80% of the students have got it right. And if you see the whiteboard, I had drawn the schematic, and in the schematic, if you are talking about a heat pump, then we are talking about this effect. Okay, heating effect. So this is the desired effect. Hello, ma'am. Whiteboard is seen. Whiteboard is seen?
No, sir.
No. Okay. Now it's seen?
Yes, sir. Yes.
Okay. So in the heat pump, uh, the heating effect, that is in my diagram, I showed it by QH. This is the desired effect. Okay, we are interested in heating this room. This is a space we are interested in heating by using a heat pump. Okay, so our objective of buying or using a heat pump is to see that the room gets heated. So the desired effect in case of a heat pump is QH. Whereas when you are talking about a refrigerator, we are interested in lowering the temperature. Okay, so for lowering the temperature, we are interested in refrigerating effect or cooling effect. So the cooling effect, or what is called as a refrigerating effect, is the desired effect in case of refrigerator. So obviously, in your refrigerator, the desired effect is QL. Okay, and in case of heat pump, the desired effect is QH. Okay, so those who are saying that it is the same in both the case, they are wrong. Okay, so that is the answer. Now, just to check whether you have seen the video. Okay, there is some small correction in the question. The Carnot, the spelling is wrong. Okay, I have made some typing mistake there. So according to Carnot theorem, no heat engine can have an efficiency greater than the Carnot engine. Okay, I am asking you this question to check whether you have understood the Carnot theorem or not. Okay, there was a video on Carnot theorem, a proof from Carnot theorem, and this your answers would help me understand how many of you are seriously watching the videos. Okay, so that is the reason of giving this question. Okay, so let me close the poll. About 86% of the students have got it correct. According to the Carnot theorem, if you are able to see the board, whiteboard, I have drawn one schematic. It's seen. The whiteboard.
Yes, it is seen.
Okay. So I have drawn a schematic wherein I have shown a Carnot engine and irreversible engine. So a Carnot engine is operating between TH and TL, and irreversible engine is also operating between TH and TL. Okay, in that case, according to the Carnot theorem, this engine, this engine would always be more efficient than this engine. This engine would always be more efficient than this engine. Okay, so no engine can have an efficiency greater than the Carnot engine while operating between the same two temperature reservoirs. This is what is the Carnot theorem. I hope almost 86% of the students of the 80% who have voted, they have understood this. So this is good enough. So please note that the correct answer is true. Now this is to check some concepts which we had discussed earlier. So this is about the concept of perpetual motion machine of the first kind. Okay, so again, looking at the responses, it appears that almost 80% of the students understood this. Okay, and let me close this. Now, let me show you this perpetual motion machine of the first kind. You see, I had drawn a schematic of a perpetual motion machine of the first kind. It is a machine, it is an imaginary machine which would violate the first law. It means that this is a machine which would produce work. It is an imaginary hypothetical machine which will produce the work without any heat input, and which is not possible according to first law. This is not possible according to first law. So this is the violation of first law. And even doing a thought exercise that we can have such kind of machine which is going to produce work without any heat input is impossible to imagine. Okay, so the correct answer is it is correct that perpetual motion machine violates the PMM1 violates the first law of thermodynamics. Now this is about a Carnot engine. Okay. So the question is about a Carnot engine, and it is asking you are asked whether it violates the second law or not. Okay. So 40% of the students are confused. Okay. 40% of the students are confused. So the answer is Carnot engine is an imaginary engine, okay, which does not violate the second law. Okay. If you are able to see the whiteboard, I have drawn the Carnot engine, and you see that even in the Carnot engine, the heat is rejected. Even in the Carnot engine, the heat is rejected. The only thing is that the Carnot engine, the heat rejected is the least. Okay, and the work produced is the maximum. So it doesn't mean that Carnot engine violates the second law. Carnot engine, in fact, obeys the second law, and it is the engine which produces maximum work while rejecting certain heat. It produces maximum work while rejecting certain heat. So that is a Carnot engine. It does not violate the second law. The second law says that heat rejection has to be zero, but in the Carnot engine, the heat rejection is not zero. So please note that this 40% of the students who are saying that it is true, they are wrong. Okay, they need to reflect on this thing that Carnot engine does not violate the second law. It rejects the heat. Okay, so it does not violate the second law. I hope that is clear to you now. And if it is clear, I hope you should be able to answer this. the answer is it is true that Carnot engine has a maximum efficiency. Okay, so I'm closing the poll now, and let me now solve one involved problem. Involved in the sense that it is a bit difficult. Okay, the question you can write down. I'm dictating the question, and it is also seen on the white screen. You can take down this question and try to draw the schematic of this. Okay, so a Carnot engine operating between 600 degrees centigrade and 40 degrees centigrade. A Carnot engine operating between 600 degrees centigrade and 40 degrees centigrade drives a Carnot refrigerator. Operating between 40 degrees centigrade and minus 20 degrees centigrade. 40 degrees centigrade and minus 20 degrees centigrade. The combined work output of this two, is 360 kilojoules. The combined work output of this two is 360 kilojoules. 360 kilojoules. The heat transfer to the engine is 2000 kilojoules. Heat transfer to the engine is 2000 kilojoules. You are required to calculate the cooling effect or refrigerating effect. Okay, you are required to calculate the cooling effect or refrigerating effect. Okay, I want you to calculate this and put down your answers in the question column. Okay, I want you to calculate the refrigerating effect, calculate it and put down your answers in the questions column along with your names. You draw the schematic first. So I hope you have taken down the question. I'm going to rub this right up and I'll be helping you draw the schematic. Okay. You are supposed to find refrigerating effect or cooling effect. What we are supposed to find is the refrigerating effect or cooling effect. What is refrigerating effect and what is the refrigerating effect? It is the desired effect of the refrigerator, which I had shown you during my earlier part of the lecture. Okay, so what you are required to find is the refrigerating effect. I will draw the schematic, and if it is not clear to you, it would be clear now. Okay, so we are talking about different temperatures. So one is the temperature of 600 degrees centigrade. Okay, so let us say this is the 600 degrees centigrade temperature. 600 degrees centigrade temperature, and this from this source there is a heat transfer to the engine. This is a reversible engine, Carnot engine. This is the Carnot engine. Okay, Carnot heat engine, and this engine is rejecting the heat. This engine is rejecting the heat to the sink, which is maintained at 40 degrees centigrade. 40 degrees centigrade. Okay, so obviously this engine is going to produce certain W work. Let me call this as W1. This is W1. Okay, now what is given is that there is a refrigerator, a Carnot refrigerator. There is a Carnot refrigerator, and this Carnot refrigerator, this is your Carnot refrigerator. This Carnot refrigerator is operating between 40 degrees centigrade, and it is extracting the heat. It is extracting the heat from minus 20 degrees centigrade. Okay, let us call this as QL. Okay, and let us call this as QH. Okay, whatever. You can use any notation, that is not important. QH. Okay, I'll call this as QH. I'll call this as QR, heat rejected. Okay, and what is given is that this work which is produced from the Carnot engine is supplied to the refrigerator, and in spite of supplying this, you are still left with the surplus. You are left with the surplus extra work, which is the net output. Okay, and that net output is given to be 360 kilojoules. 360 kilojoules. So if this is W1 and if this is W2, so W2 is consumed by the refrigerator, W1 is produced by the engine, and what is given is W1, or W1 means W of the heat engine, minus W2, which is the energy consumed by the refrigerator, is equal to 360 kilojoules, is equal to 360 kilojoules. Okay, one more information is given. That information is that this engine is supplied a heat equal to 2000 kilojoules. 2000 kilojoules. Okay, 2000 kilojoules is the heat which is being supplied to this Carnot engine. And what you are asked is the refrigerating effect. That is, this is to be found out. This is to be found out. Okay, so I hope you are clear now what is to be found out. So try to solve this. Note that this is an ideal engine and this is the ideal refrigerator. So you can use the expression for efficiency in terms of temperature for this engine, and you can use the expression for COP in terms of temperature for this refrigerator. Okay, so this is the hint which has been given to you. Okay, and note that these temperatures are to be converted to Kelvin. These temperatures, all these temperatures are to be converted to Kelvin. Okay, so try answering this. Try to solve this. First, you find the Carnot efficiency. You tell me the value of Carnot efficiency first. You can write down and find the Carnot efficiency and tell me the efficiency of this engine. Tell me the efficiency of this engine. Okay. If you have got the answer for efficiency, you put down the answers in the answer column. Okay, efficiency. Carnot efficiency. Aditya has got it right. Efficiency, Carnot efficiency. Aditya Hange has got it right. Parikshit Pawar is wrong. Atharva Mahajan is uh, slightly away from the mark. Pranav Mate and Omkar Fekle has got it right. So it's simply a question of substituting the values. Okay, I don't feel it is wrong. Rushali has got it wrong. Kunal is right. Sairaj is right. Okay. See, the efficiency would be like this. Tanaya is right. 1 minus TL. TL is how much? 40 plus 273. And TH is how much? 600 plus 273. Okay. So that gives you the efficiency, which is 64%. 64%. Okay. Vedant is wrong. All right. Now, once you have got the efficiency, you need to find this W1. So you first find W1 now. Why to find W1? Because once you get W1, you can find W2. So you find W1 and tell me the answer for W1. Find W1 and you tell me the answer for W1 now. Kunal Ranade is right. Tanaya is right. Sairaj is wrong. Pranav Mate is closer to the answer. Now it is pretty straightforward. Pretty straightforward. Aditya is also closer to the answer. Aditya. Deepak Bhogir is wrong. Deepak Bhogir is wrong. Nikhil Pardesi is right. Gunjan is wrong. Gunjan Sarod is wrong. Nikhil Pardesi is right. So you need to be very smart in answering this. Pranav Mate. Okay, you are expressing the answer is some unit. This Kunal Patil is wrong. Kunal Tukaram, roll number 5 is correct. Okay, let me explain you this. Saurabh Jadhav is correct. Okay. See, as I had explained you, this is the engine, and the efficiency of the engine is what? It is the work output. So in this case, W1 upon the heat input. So obviously W1 would be QS into the efficiency. QS into the efficiency. QS is given to be 2000. So 2000 into 0.642. 0.642. Okay. So that comes to 1284 kilojoules. 1284 kilojoules. So you have found W1 now. So you find W2. Find W2 now. Find W2 now. And find the COP of the refrigerator. Find the COP of the refrigerator. And tell me the answers. Find W2 and the COP of refrigerator. Find W2 and COP of refrigerator. Abhijit is correct. Sairaj is correct. You find the COP also. COP of the refrigerator. Sushant Kanade is correct. Kunal Ranade, COP. Correct, COP. Kunal Ranade is correct. COP Tanaya is also correct. Raju has got the W right. But you find the COP, that is more interesting. So Omkar is very fast in answering. We'll take your answer, Omkar, don't worry. Parikshit Pawar, you are right. Zai, you are also right. Okay, so look at this now. So you are now following some of the students at least. So this is simply a you need to find W2 means W1 minus 360. Okay, W1 minus 360 would be W2. W1 minus 360 would be W2. So 1284 minus 360. So that comes to 924. That comes to 924 kilojoules. Okay, because this is how much? This is we have found it as 1284. So this is 1284. So 1284 minus 360 would be 924 kilojoules. So now we have this problem. So look at this problem now. So this is a problem of refrigerator now, and wherein you are given the work input to the refrigerator, which is 924, and it is a Carnot refrigerator. So for a Carnot refrigerator, you know how to find COP. So COP for a Carnot refrigerator would be TL upon TH minus TL. Okay, again you need to not forget about the Kelvin per term. So this has to be converted to Kelvin. So 273 minus 20. Okay, This is Kelvin. This becomes your TL, and this is TH 40 plus 273. Okay, 40 plus 273. So once you get the COP, so the COP value, substituting this value TL and TH, as all of you, many of you have got, it comes to around 4.2. Okay, and once you get 4.2 as the COP, okay, you know that refrigerating effect upon work is the COP, and hence you will get the required answer QL. So write down the required answer, find out the required answer QL, find the required answer QL. So Sharwari is correct. Jai, you have made some mistake in the units. Jai, check your units. Sairaj is correct. Gunjan is correct. Why you are getting slightly less answer? I don't understand. Pranav Mate. All right. So if you multiply it correctly, you'll get the answer at around 3890. Around 3890, which many of you have got. Okay. Depending upon up to what accuracy you are going to solve this, your answers will slightly change. Doesn't matter. We are interested not in the correct answer as such. We are interested exact answer. I mean to say, we are interested in the method here. So please ensure that you can calculate now. You can calculate the uh, refrigerating effect. Okay, refrigerating effect as by first calculating the maximum COP as TL upon TH minus TL, and by that using the generic expression for COP, which is QL upon W, refrigerating effect upon the work input. Okay, now I want you to calculate. Okay, now this is more interesting. I want you to calculate the heat which is rejected. Okay, now look at this problem. Okay, this reservoir is a single reservoir. Okay, just let me use some other pen. Let me use a blue pen here. Okay. So look at this way. This is a single reservoir. So now one question is, and final question is, you need to calculate how much is the total heat rejected to this reservoir, which is at 40 degrees centigrade. What is the question now? Calculate the heat rejected, total heat rejected to the reservoir, which is at 40 degrees centigrade. So if you look at this carefully, you need to calculate this QH and you need to calculate this QR. Okay, you need to calculate QH, you calculate QR, and then add up these two. So I want you to calculate QH and tell me the answer. I want you to calculate QR and you tell me the answer, and then you can sum up the two, and then you can sum up the two. Okay, calculate QH, calculate QR, and then calculate QH plus QR, which is nothing but the heat which is rejected to the reservoir, which is at 40 degrees centigrade. Heat which is rejected to the reservoir, which is at 40 degrees centigrade. So you calculate and tell me that. Calculate QH, calculate QR, and hence the final answer of the heat rejected to the reservoir. Okay. So let us see how many of you can answer this. I hope I am clear about the question. You are supposed to find what is the value of QR, what is the value of QH, and hence the total Q. Anybody is answering this? Okay, Gunjan has got some answers. Aditya has got the total answer. Zai, Zai is correct. Zai is correctly calculated. Vedant has partially answered QR. Aditya, what you have calculated, I don't know. Rohan, you need to check your answer. Rohan, you need to check your answer. Your answer is wrong, Rohan. Deepak, Tanaya has got it correct. Kunal, Tukaram, Nikhil has got QR correct. Ajinkya has got QR correct. Ajinkya Patole. Onkar Fekre has got QR correct. Vivek has got QR correct. Nikhil Pardesi has got QH closer. Pranav Mate is closer to the answer. Yes, Pranav, you are right. Gaurav Surse, you are right. So it's basically now let me, Yash More is answering. Kunal has got it correct. Kunal. Ganesh Shikare, you need to check your answer. Ganesh, you are wrong. Ganesh Shikare, recalculate. Archit, you are correct. Atharva Mahajan, your QR is correct. What about QH, Atharva? All right. Let me show you now. This is many of you are answering it, and I'm happy that you are answering it. See, look at this diagram. If you have followed the diagram, it would be very clear to you. This is 2000, and W1 you have calculated as 1284. 1284. Okay, W1 is 1284. So obviously, the difference between these two would be QR. Difference between these two would be QR. So if you take it as approximately 1284, so this would be 716. Right? This would be 716. So QR would be 716, 717, depending upon your accuracy. Right? So this is what is QR. And if you look at QH, again, this is from energy balance. You have got QL. QL value is how much? QL is how much? How much is QL? We had calculated that. Tell me the value of QL. 3890. Okay. So QL was 3890. Right. So this is 3890. Or closer to this, whatever. And this is 924. So if you look at this sketch clearly, so you do an energy balance and you get QH. So QH is W2 plus QL. QH is W2 plus QL. Okay. So that will give you the value of QH. That will give you the value of QH, which comes closer to 4820, whatever. Okay. 4820 or 48, depending on again the significant digits you are taking. So this would be QH, I guess, right? 4820. And then you sum up this two. This you sum up with this, and you get the final answer. You get the final answer. Okay. So I hope that it is clear to most of you, right? If you understood this sketch, okay, if you understood, correct, roll number 46, you are correct. Okay, so if you understood this sketch, if you are able to draw this sketch correctly, then the calculations are pretty simple. Calculations are pretty simple. So this problem requires the concept of, you must have understood what is a Carnot engine. You must have understood what is a refrigerator, and you must have understood how to write the energy balance. Okay, if you are comfortable with all these three, that is, if you are comfortable with what is Carnot engine, if you are comfortable with what is a Carnot refrigerator, and if you are able to do the energy balance correctly, then you should be in a position to solve this kind of tricky problems. Okay, so I want you to practice such kind of tricky problems, and then revise yourselves at home, and when we take a test on this portion, you should be able to score good marks on this. Okay, so I'll stop this. Thanks for joining. Okay, have a good day. Thank you all of you. Let me end this webinar.